Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ugwabela Maths. And without any further ado, let's look at these questions that we have here. Ah, Okay, so we are given question 4 on momentum and impulse. It says a truck of mass x traveling at a velocity of 20 meters per second to the right on a straight horizontal road collides head-on with a car of mass y traveling at 10 meters per second to the left. The collision between the vehicles is inelastic, so meaning that kinetic energy is lost during the collision. So the vehicles stick together during the collision and move to the right. So the vehicles have a combined mass of 2,300 kg and a kinetic energy of 258,750 joules. Then 4.1 says, state the principle of conservation of linear momentum in words. So quickly on that one for 2 marks, we say that the principle of conservation of linear momentum states that the total linear momentum in an isolated system. So use the word isolated system and not closed system. So the total linear momentum in an isolated system is conserved. Right. Okay, so now we have 4.2. It says calculate the speed of the vehicles after the collision. And then there is a 3-mark question. And then we already know with 3-mark questions, there is just formula substitution and the correct answer. So we can say that here we are given the kinetic energy is 258,750 joules, and then we are to calculate the speed. Now, if we can just use the formula that says EK is equals to half mvf squared, then we can substitute our value for the kinetic energy here. And then there we go, is equals to, remember the combined mass, we are to calculate the speed of the vehicles, meaning when they're now combined, they have a mass of 2,300. And then v squared, this point we know we must divide both sides by this half, 2,300, and then half 2,300. When you punch all that into your calculator, you get 225, which if you then have to square both sides to get rid of that square there, then you will be left with 15 meters per second, right? So this will be 15 meters per second. And then remember, this is speed. It's only a scalar, so we do not need to indicate the direction, right? So, okay, now we have the final velocity with which the system of vehicles move with, or the combined vehicles move with. And then now 4.3 says show by means of a calculation that the truck has a mass of 1,916.67 kg. So we have our formula for the principle of conservation of linear momentum. Says momentum initially is equals to sum of momentum finally. And then let's indicate that we're going to take our right as the positive direction. And then since we are told the case here is the truck and the car here were moving individually or separately, then after they collided, they stick together and started to move as a unit. So we know that our equation should be m1 v1 plus m2 v2, since they were moving separately initially, but then after collision they then stick together and move together as a unit. So that means they will share the final velocity. Okay, so now we do not have the mass of the truck, but then we'll indicate the mass 1 as the mass of the truck, and then this here will be the mass of the car. But the mass of the car, since we know that the combined mass is 2,300 kg. We can represent the mass of the car as 2,300 minus the mass of the truck. So that is to say, whatever mass that we find of the truck, if we then subtract it from the 2,300 kg, we can be able to determine the mass of the car. So we are expressing the mass of the car in terms of the mass of the truck, so that we then have the same variable to work with. Right, so our mass one, I will say this is just the mass of the truck, and then velocity of the truck initially was 20, so it's positive because it's going to the right. And then what is a mass 2? That's the mass of the car, but then I'm gonna represent it as 2,300 minus the mass of the truck. Right, and then the velocity initially of the car was 10 meters to the left, so I need to indicate it as negative. And then this is mass 1 plus mass 2. Remember, combined it's 2,300, so I can just write 2,300 here. And then the final velocity is the one that I had calculated in 4.2, which was 15 meters per second to the right, so it's positive. So okay, in calculating here, this will give me 20 mt. And then if I take the 2,300 multiplied by negative 10, it is supposed to give me negative 23,000. And then here, this is supposed to be positive 10 mt. And then now, if I multiply the 2,300 there with the 15, so 2,300 multiplied by 15, this is giving me 34,500. So we have 34,500. And then now can say 20 mt plus 10 mt is equals to 34,500 plus the 23,000. Right. And then this will give us 30 mt is equals to, when we add those ones, on the right, we are getting 57,500. And then we can then now divide both sides by 30. And then let's divide there by 30. So this is going to give us 1,916.6667. So if we round off to 2 decimal places, it's 67 kg. And then just like that, we have proven that the mass of the truck is 1,916.67 kg. If we are interested in the mass of the car, then it's simply taking the 2,300 minus this value here, and then just like that we'd find the mass of the car. But then that was not the question right there. We were just supposed to find the mass of the truck, so which is why I had to represent the mass of the car in terms of the mass of the truck. Right, okay, now that's it for that former question. Let's now go to 4.4. Now 4.4 is saying hence, and then we do understand when the question says hence, it means from whatever that you have proven above or from whatever that you have calculated above, use it in order to answer this question. So 4.4 says hence determine the magnitude of impulse experienced by the truck. Now we do know the formula for impulse is simply F net times delta t. But then obviously we do not have the magnitude of the net force, and then we also do not have the magnitude of the time, or we don't have time there. So obviously we will now approach the impulse momentum theorem, which says that F net delta t is equals to change in p. So in other words, if we are interested in finding the impulse of an object, and then we do not have F net and delta t, we can look to calculate the change in momentum. So in other words, the impulse of an object is equals to its change in momentum. Right, so that means if we are looking for the impulse, we can calculate the change in momentum, and then we know that whatever value that we get from there will be the same as the impulse. Right, so that's the impulse momentum theorem. So now we have change in p is equals to mass, final velocity minus final initial velocity. Our mass is the combined or the one experienced by the truck, so it's not combined. It's the one experienced by the truck. So we just got the mass experienced by the truck in 4.3 for the hands part. So 0.67, and then our final velocity. Remember, the final velocity is the one that we calculated here, which was the speed of the vehicles after the collision. So we had calculated that one to be equal to what? It was 15, right? And then initially, what's the mass of the truck? We can see it there, 20. So both of them are positive because it was still going to the right. And then when we multiply that, we are going to get negative 9,583.35 kg meters per second, right? But this is the SI unit for the change in momentum. But what we are interested in is the impulse. So we have to conclude and say, therefore, the impulse will be equals to 9,583.35 Newton second, right? Because now we have to write it in the SI unit of the impulse, which we do know that the impulse is the product of the net force and the time taken for the net force to act on an object, this being in Newton and your time being in second. So the SI unit for impulse is Newton second, right? And then just like that, we have our value, right? So that's how you were supposed to approach this question here for 12 marks taken from your KZN Prelim 2024 paper 1. So it was a pretty interesting question. And then you know what to do. If you've enjoyed the lesson, please press the thumbs up button. And then also do not forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.